So firstly, I'd like to give you some information on the UCD Maths Support Centre. And secondly, we'll actually look at our research project, the problems we met and then the challenges that then faced us. Thirdly, we look at the pilot study, which again, we began in February 2014. And then we look at our actual data collection. And finally, some details of the preliminary analysis of our data. So UCD Maths Support Centre opened in 2004. The UCD, University of the University College Dublin, has 26,000 students on campus. So it's a large university. When the student, originally when we opened the student centre, it was intended for first years, well, mainly for first years. But very quickly we target our services to all levels in UCD. The students that come to us, they may be from a mathematics-related degree programme, or they may be a service match module. Service match module, for instance, could be agriculture or commerce. Or they could be a student who's taking no mathematics module, and they could be students from psychology, medicine, social science, geography, and many other areas. And the numbers coming to our Maths Support Centre have been increasing significantly year by year. When a student first comes into the Maths Support Centre, and this is going back to 2009, the tutor logs onto a computer with their student number, and initially they add data such as their name, their programme, but each time they add the module for which they're seeking help. When the student is finished, the tutor goes in onto the same database and they add in the details of the topic they've covered with the student. Now, our talk is going to be mainly about these tutor entries, and we're going to refer to them as topic entries from now on. Now, there are 25,000 of these topic entries on our database. Also, as Mark was referring to this morning, the topic entries are available to the module lecturer on a real-time basis. That is, as soon as the tutor puts it up, which is straight after the student leaves, it's available to the lecturer. And this is a major thing and is appreciated, as Mark says, by the higher-ups in the university. So it's a sort of an extension of the work of the Maths Support. The details of this 25,000, and I'll show you an example of it, wasn't sufficient for the research purposes that we had planned. The detail wasn't sufficient, and on top of that, there was no easy way of extracting the information from the database. So this actually was the aim of our research: identifying university students' mathematical trouble spots and developing effective supports and analysis of Maths Support Centre data. And that's what I'll be mainly talking about. So these were the examples. These were the type of examples that went up. The thing is, they are definitely useful. There's 25, they're not anecdotal, they're actually problems that students came in with. But of course the detail isn't sufficient. But we are thinking of looking at these 25,000 now, because it's a huge data. So that we could actually extract the information, we began the project in September, and from the original data we were able to pick up certain areas that we knew students had problems with, and we coded all these areas. So these are the codes that we put up. Oh yeah, so of course the first thing we got ethical approval. So we got that in December, and then we decided then that we would set up a pilot study in the second semester. That's in 2014. And before that, we met with our more experienced tutors. Now, firstly, to inform them about our research project and the important role that they were going to play in it, because of course they were going to enter the topic entries. And we then asked them for any suggestions they made that would improve the topic entries without overburdening the tutors. And they came up with a number of suggestions. But during that talk with the tutors, we needed to tell them, look, this is what we're looking for. So we gave them a number of examples. This is just one of the examples. And I think nearly everyone here is mathematical to understand. If you look at the first one, you can see it's coded. A was for algebra, S was for science, and F was for functions. And the bottom one was also A for algebra and FR for fraction. So if you look at the first one, how much information is it giving us? It's really not telling us what was the problem with limits and continuity. It's not telling us what was happening at first principles. Was it x plus h to be squared they couldn't expand, or was it x plus h to be cubed, or what exactly was the problem? So we're not really getting the detail there, and that's why we gave that specific question. That's not sufficient for the research that we were undertaking. The second one is a problem simplifying an expression, the common denominator, and very obviously you can see immediately the student wasn't able to get a common denominator, and the fraction is added because they couldn't get the algebraic fraction. So this is how we, so as a result then of this meeting, the tutors suggested ways that we might improve the topic entries. So we were then ready to start our pilot study in February 2014. So these were the consequential improvements that the tutors suggested. They suggested extra category entries from their own experience. They also suggested that they would put up mathematical expressions or equations in LaTeX if they were familiar with LaTeX. But probably the most important was they suggested the use of carbon copy APADs. So you just put a carbon copy in, and while the tutors were working with the student, they would work on these. And so the top copy was given to the student, and the rest was maintained in the Math Support Centre. So there was a lot of detail in these. So at the end, during the pilot study, what I would do is I would check the database entries and then take the A4 pads and go through those and look and compare them. And if I found the information wasn't sufficient, I would go back to the tutor and say, you know, what exactly did you mean here? So in other words, really that our pilot study was a training program for the tutors as well as for us as to what was suitable, what we were going to get up and what we were going to do in the real study. So these were at the end of the pilot study. These were just a few of the data entries that were on it, and you can see they are actually clearer. You can see where the problem is, and they're all correctly coded. The coding, of course, was essential because that was how you download it from the database. Okay, and so now we were ready for our data collection, our true data collection, in September 2014. So once again, we met with the tutors, and the idea was really to set our date for collection, which we set as the end of September. It was when the Math Support Centre was opening, and we decided we'd do it for 8 weeks. And the reason for that was that if we went beyond the 8 weeks, you were into exam time, and there literally wasn't the time to put up the same sort of data. So we were just taking it for the 8 weeks. The other thing we asked the tutors, was there any more suggestions they could come up with? And the biggest thing and really the only thing, was they found the coding was impossible to remember, like A for algebra. There were so many different ones. They found that difficult. And the idea was, I thought I'd simplify their actually putting up the data, make it A. But it didn't work because they couldn't remember it and wasted more time. So in actual fact, this was our new coding. I don't know where you'll see it. And it's just the new codes were more expanded. So A became ALG. P for probability became prob, etc. So, and this one was very successful. They found this worked. So now came the data collection, and this is where the work became really intensive. There were about 50 entries approximately each day. So what I did at the end of the day is I went and I collected all the notepads from the various tutors that had been on that day. And then I went home, I went into the database, and I checked in the database what the tutor had added, and then looked at the book. And again, sometimes I would go back then to the tutor, and I would say, look, I'm not clear exactly what you meant here, and they would clarify it, and I would add something onto the database. Or I might just put a note, depends on the tutor and how often I met them. I'd put a note in, you know, what did you mean here, or was this what the intention was? And to give you an idea of this, this was a particular entry made by a tutor. I'm just going to use this as an example to show you the whole process. So on top she says the surveyors are looking at a cliff top, they look at the angle 24, and she's just summarised the actual question there, and then what she actually did she's put underneath. And you can see now the new coding is in there and it is more explicit. So now let's look at the notebook or the notepad, whatever you like to call it. So this is the first half of the notepad. Actually, I find it, I don't know whether you can see this on it, but you see at the very top, there's a time and a date. So it's 10:45 on the 6th of the 11th. So that was and then on the right-hand side, the initials of the tutor. On the left-hand side, but covered, are the initials of the student. So the reason for that was that I could then trace that straight into the database because my key in the database was date and time. So it was very easy to get the exact entry and match them. So you can see what happens. You can see that she drew out the original problem, and that then she split it into the two triangles. But then you'll see in red, you're not going to be able to see what my query was, but I'll show you what my query was from this particular one. So it was, were these the mathematical, so I want to know from her, were these the actual mathematical trouble spots the student had? How to start by taking two right angle triangles, finding two equations and solving the simultaneous equation. Now if you look at the second half of the same page, you can see that underneath the red, you'll see yes. So she's come back to me and said, yes, these were the actual problems. But on the original, on the coding, she had put algebra. So when I looked across on the left-hand side, and again, it's probably, I don't know if you can see it, it said 5x equal 10. So this is a consistent problem. It came down to working out simultaneous equations. But they weren't able to, they were only able to go so far. So she went then and said, okay, look at this, 5x equals 10, so x equals 2. And then further down, under that, she says 20x equals 10. Again, because the student had a problem with fractions, even fractional algebra. So that was what we got. That's one, and there were 50 of those every night for 8 weeks.
8 nights.
Yes, it was a lot of work. So then the other thing is, when I went back to the tutor and I had clarified things with the tutor, I would add extra data into the database. So and all of my entries were made with square brackets NC at the beginning and the end. So it was quite clear what I had added. So Tutor said student did not know how to start by taking 2 right angles. So I had that sort of information, the extra information was added in there, and that's all up on the database for each entry. We're come down now. There were a total number of student visits over those 8-week period of 2012. There were 2012 student visits over the period. When I spoke to the tutors, I suggested that they put any coding that they thought was correct. So if they thought there was any slight use of a coding, add the coding. I will take out any of the coding, but I didn't want it not put in because I was never going to catch it. So what happened then was that I'd go through the coding, and just to explain, even though there's 2012 student visits, each student visit could have had 3 or 4, 5 codes. So in actual fact, the tutors would have put up all these codes. So in algebra, there were 315 algebra codes that the tutors had coded. But then I went through the coding and I took out the ones that I didn't think were specifically algebra. And we ended up with 95. So I think approximately anyway, maybe 92, I don't know, 90 something anyway. So in other words, they had been very particular and they'd put in everything. It wasn't exactly true. Then what under each code then, I extracted each area. So in other words, we'd extract the complex numbers, we extracted the algebra, we extracted under all the codes, we just extracted them out. And then the next thing is there is ongoing a third validation of the code. So the tutors validated the code first. I then re-validated that code by extracting the ones that I didn't think were correct. And now both Anthony and Maria are going to do the third validation. So they will see, yes, this should belong to algebra. No, this maybe should belong to something else. So that is ongoing at the moment. So this is a preliminary count of the areas. There's 90, I don't know whether you can see it again. There were 90 algebra, 92 statistics, 95 matrices, 88 vectors, 96 differentiation, and 52 graphs. Now what I found really interesting there was Project Maths is really concentrating on statistics. They don't cover vectors. And yet the number of queries that we were getting were more or less the same for both. It just made me wonder. A lot of the work now will be done over the summer, actually looking at each area. And the idea then is maybe to, if we get common areas, I mean, there were actually 315 different modules came during those 8 weeks. So it's a lot of modules. So if we could take something that was common across a few modules and maybe produce some video for it, whatever, that's not decided yet because the analysis has to be completed. So that's it. Thank you very much.